Welcome to Cambridge IGCSE Physics, Lesson 10.1, What is Momentum? Today we explore one of physics' most fundamental concepts. Momentum appears everywhere in our world, from moving vehicles to colliding particles. Understanding momentum is essential for analyzing motion and forces. This lesson provides the foundation for advanced topics in mechanics and dynamics. Let's examine our learning objectives for today. By the end of this lesson, you'll be able to, first, define momentum as mass multiplied by velocity. This definition connects two fundamental quantities in physics. Second, recall and use the equation P equals mv, where P represents momentum, m represents mass, and v represents velocity. Third, understand momentum is a vector quantity, meaning it has both magnitude and direction. These objectives align with Assessment Objective 1, focusing on scientific knowledge and understanding. Now let's define our key vocabulary. Each term is essential for understanding this lesson. First, momentum, which means the product of mass and velocity. This quantity measures how much motion an object possesses. Second, vector, which means a quantity with both magnitude and direction. Unlike scalar quantities, vectors require directional information. Third, mass, which means the amount of matter in an object measured in kilograms. The symbol P represents momentum, m represents mass, and v represents velocity. Momentum units are kilogram meters per second, combining mass and velocity units. Let's explore our first core concept. The fundamental principle states that momentum quantifies motion by combining mass and velocity. This means momentum tells us how much motion an object possesses. The definition is, momentum is the product of an object's mass and velocity. Mathematically, we express this as P equals mv, where P represents momentum measured in kilogram meters per second, m represents mass measured in kilograms, and v represents velocity measured in meters per second. The diagram illustrates a 5-kilogram object moving at 10 meters per second. Notice how momentum equals mass times velocity, giving 50 kilogram meters per second. This principle is fundamental because it connects an object's physical properties with its motion. Now we examine momentum's vector nature. This follows fundamental physics principles. Vector properties include magnitude and direction. Magnitude means the size of the momentum value calculated using P equals mv. Direction means momentum points the same way as velocity. We represent vectors using arrows showing both magnitude and direction. The diagram shows two objects moving in opposite directions. The blue object has mass 2 kilograms, velocity plus 15 meters per second, giving momentum plus 30 kilogram meters per second. The green object has mass 3 kilograms, velocity minus 10 meters per second, giving momentum minus 30 kilogram meters per second. Notice how opposite directions give opposite signs. Let's work through our first example. The problem states, calculate momentum of a 1,200 kilogram car traveling at 25 meters per second. We are given mass equals 1,200 kilograms and velocity equals 25 meters per second. We need to find momentum P. Step 1, write the equation. We use the momentum equation, which is P equals mv, where P is momentum, m is mass, and v is velocity. Step 2, substitute the values. We write P equals 1,200 kilograms times 25 meters per second. Step 3, calculate. 1,200 times 25 equals 30,000. Step 4, state the answer. The result is 3.0 times 10 to the 4th kilogram meters per second to two significant figures, with units of kilogram meters per second. Example 2 applies the same principle differently. The problem is, find velocity of a 0.5 kilogram ball with momentum 15 kilogram meters per second. The data shows mass equals 0.5 kilograms and momentum equals 15 kilogram meters per second. Now we analyze. First, rearrange the equation. Starting with P equals mv to find velocity, we divide both sides by mass, giving v equals P divided by m. Second, substitute values. We write v equals 15 divided by 0.5. Third, calculate the result. 15 divided by 0.5 equals 30. Fourth, check units match. Kilogram meters per second divided by kilograms gives meters per second, which is correct for velocity. The diagram shows the algebraic rearrangement process step by step. Mathematical skills are crucial in physics. Let's examine 3 key skills. First, equation rearrangement. When we need to find a different variable, we rearrange algebraically, starting with p equals mv, where p is momentum, m is mass, and v is velocity. To find mass, we divide both sides by velocity. The result is m equals p divided by v. Second, unit conversion. To convert from grams to kilograms, we divide by 1,000, so 1,000 grams equals 1 kilogram. This ensures consistent SY units throughout calculations. Third, scientific notation. Large momentum values like 45,000 kilogram meters per second become 4.5 times 10 to the fourth kilogram meters per second. This notation simplifies calculations and maintains appropriate significant figures. Now practice what you've learned with these three questions. Question 1 is basic level. It asks, calculate momentum of a 2 kilogram object moving at 8 meters per second. Use the equation P equals mv directly. Question 2 is intermediate. It states, find mass of an object with momentum 120 kilogram meters per second and velocity 15 meters per second. This requires you to rearrange the momentum equation. Question 3 is advanced. The question is, compare momenta of a 1,000 kilogram truck at 20 meters per second and an 800 kilogram car at 25 meters per second. This tests your analytical skills by requiring 2 calculations and comparison. For all questions, remember to show you're working clearly, include units in every step, and check your answers make physical sense. Physics principles power our modern world. Let's see how today's concepts apply in practice. In vehicle safety, crumple zones reduce the rate of momentum change during collisions, decreasing forces on passengers and improving survival rates. Engineers calculate momentum changes to design safer vehicles. In sports science, analysts study momentum in ball and player collisions to improve performance and reduce injury risk. Understanding momentum helps optimize technique and equipment design. In space technology, rocket propulsion relies on momentum conservation principles, where expelled gases create equal and opposite momentum in the spacecraft. These applications show why physics matters. Career-wise, physics knowledge leads to automotive engineering designing safer vehicles, sports analysis improving athletic performance, and aerospace design creating advanced spacecraft. The concepts you learn today become tomorrow's technological breakthroughs. Let's review the solutions. For question 1, the answer is P equals mv equals 2 kilograms times 8 meters per second equals 16 kilogram meters per second. This is correct because we applied the momentum equation directly. For question 2, we rearranged to find m equals p divided by v equals 120 kilogram meters per second divided by 15 meters per second equals 8 kilograms. Notice how units cancel correctly. For question 3, truck momentum equals 1,000 times 20 equals 20,000 kilogram meters per second. Car momentum equals 800 times 25 equals 20,000 kilogram meters per second. Surprisingly, both vehicles have equal momentum despite different masses and velocities. Now, exam success tips. First, always show you're working. Even if the final answer is wrong, you earn marks for correct method. Second, include units in every step of calculation. Third, check if your answer is reasonable. If you calculate momentum of 10 for a car, something is wrong. Fourth, read questions carefully. Command words tell you what to do. Calculate means find a numerical answer. Describe means state features. Explain means give reasons. Let's summarize today's lesson. The key points to remember are, first, momentum equals mass times velocity, expressed as P equals mv. This definition connects an object's physical properties with its motion, providing a measure of how much motion the object possesses. Second, momentum has vector nature, meaning it possesses both magnitude and direction. The magnitude comes from the calculation mv, while direction matches the velocity direction. Third, always use kilogram meters per second as the SI unit for momentum. Consistent units prevent calculation errors. For further study, review momentum equation rearrangements to solve for mass or velocity. Practice vector direction problems to understand positive and negative momentum values. The next lesson covers conservation of momentum, which builds on today's work by exploring what happens when objects interact. Ensure you understand today's concepts before moving forward. Remember, physics builds systematically. Each lesson connects to the next, creating a comprehensive understanding of motion and forces.